We are on the threshold of a new space age. While Elon Musk dreams of cities on Mars and NASA prepares the Artemis mission, the question arises, why are all the leading space powers investing billions in the moon? Isn't our satellite a past stage after the Apollo missions? It turns out that without the moon, successful colonization of Mars is practically impossible. Today, we'll take a closer look at why the moon has become a strategic springboard for Martian expansion, what technologies are being tested there right now, and how lunar bases will change the future of space travel. Let's go. To understand the importance of the moon, let's look at the numbers. The average distance to our satellite is only 384,000 kilometers. That seems like a lot, but by space standards, it's just a neighbor's yard. Modern ships can get there in 3 days. Now let's look at Mars. Even with the best arrangement of the planets, it's 55 million kilometers, or a 7-month one-way trip, and in unfavorable conditions. All 400 million kilometers and almost a year of travel. But it's not just the distance. Gravity on the moon is only 1/6 of Earth's. This means that launching from the lunar surface will be much easier and cheaper. According to SpaceX calculations, launching a heavy Martian spacecraft directly from the moon can save up to 70% of fuel compared to launching from Earth. Imagine, instead of spending enormous resources to overcome Earth's gravity, we can build a real space refueling station on the moon. In 2018, NASA's Lunar Reconnaissance Orbiter spacecraft made a sensational discovery. At the bottom of the eternally dark craters at the lunar poles, huge reserves of water ice have been discovered. According to the latest estimates, only in the area of the South Pole, maybe up to 600 million tons of water. This discovery radically changes all plans for the development of the moon. Why is it so important? Water isn't just for astronauts to drink. Through electrolysis, it can be used to produce oxygen for breathing and hydrogen, an ideal rocket fuel. Modern technology allows us to produce up to 1 ton of fuel per day from lunar ice. This is enough to fuel several lunar modules or one heavy Martian spacecraft. That is why in 2024 NASA allocated $2.6 billion for the CLPS program, in which private companies develop technology for the extraction of lunar resources. The Blue Ghost mission from Firefly Aerospace, which ended in March 2025, was just testing equipment to work in lunar pole conditions. Another critical technology is building with local materials. It would be insanely expensive to ship every brick from Earth. But the solution has been found: lunar regolith, that sharp glass-like powder that COV airs the entire surface of a satellite, could be the perfect building material. Icon, a company contracted by NASA, has already developed a technology to 3D print regolith. Their printer can create strong structures by sintering lunar dust with concentrated sunlight. The first such printer will go to the moon as early as 2026. And by 2030, NASA plans to build the first semi-autonomous living modules. These technologies will be invaluable for Mars, where conditions are even harsher and shipping materials from Earth is even more expensive. However, one should not think that the moon is a hospitable place. In fact, it is one of the most inhospitable environments mankind has encountered. Let's break down the main dangers. 1. Lunar dust is incredibly abrasive and ubiquitous. It destroys mechanisms, clogs connections, and is even dangerous to astronauts' lungs. The Athena mission in 2025 failed precisely because of problems caused by dust. 2. Extreme temperatures from plus 127 degrees Celsius on the lit side to minus 173 degrees Celsius in the shade. No electronics can withstand such extremes without special protection. 3. Cosmic radiation. Without a magnetic field and atmosphere, the radiation level on the moon is 200 times higher than on Earth. But it is these challenges that make the moon an ideal testing ground. If we learn to survive here, Mars will seem almost like a resort. As you can see, the moon is not just a stage on the way to Mars. It is a necessary step, a space training camp, a scientific laboratory, and a transshipment base in one person. Having mastered the technologies of survival on the moon, extraction of local resources, and construction in extreme conditions, we will make the breakthrough to Mars not a dream, but a reality of the next decades. Which country or company do you think will be the first to establish a permanent base on the moon? NASA with its Artemis program? China with its Lunar program? Or maybe Elon Musk with SpaceX? Write in the comments. Let's argue. And if you want to know more about specific lunar missions, put a like. It will help us understand what to make the next video about. See you in space. January 2024. The American landing module Odyssey from Intuitive Machines makes a historic landing. The first private, successful mission to the moon. But the joy is short-lived. After a few hours, it turns out that the lander is lying on its side, its antennas are pointed in the wrong place, and the solar panels receive only 30% of the calculated amount of energy. This is not an isolated case. It is a system. In the last 5 years, 9 out of 11 attempted commercial missions have failed completely or partially. Why do private companies that have conquered orbital launches fail in the final meters of the lunar race? Today we will conduct a detailed analysis of all the key incidents, talk to experts and find out, is this series of failures an inevitable stage of death, allotment, or a consequence of fundamental miscalculations? Let's break down 3 key technical aspects that become fatal to private missions. First and foremost, propulsion systems. Unlike government programs, which use decades of proven technology, the private sector has to compromise between cost and reliability. Take, for example, the Hakuto-R mission of the Japanese space in 2023. The spacecraft successfully entered lunar orbit, but during descent, its engine unexpectedly reduced thrust. Analysis of telemetry showed the control system, trying to compensate for the uncalculated inclination, completely used up fuel 30 seconds before touchdown. The result was a hard landing at a speed of 5 meters per second instead of the planned 1.5 meters per second. The second Achilles heel becomes navigation. Government missions use redundant systems with backup computers. Privateers, in an effort to reduce weight and cost, often rely on a single navigation computer. This is Hat ruined Israel's Beresheet in 2019. A failure in one sensor led to a chain reaction of errors. The budget for the average private mission is 80 to 100 million. By comparison, the development of the landing system for Apollo alone cost 80 to 100 million. 80 to 100 million. By comparison, the development of the landing system for Apollo alone cost 2.3 billion in today's dollars. Companies are forced to make risky compromises. Use commercial electronics instead of specialized ones. Cut back on testing. Abandon redundant systems. In the case of Blue Ghost 2025, savings on the thermal management system caused the batteries to overheat as early as day 14 of the mission. Но возможно, главная проблема в отсутствии опыта. Команды, создающие частные миссии, часто состоят из энтузиастов, никогда не работавших над реальными лунными программами. Они повторяют ошибки, которые НАСА и Роскосмос совершали в 1960-х. Мы заново изобретаем лунную посадку, признается технический директор Intuitive Machines. При этом сроки разработки в 2-3 раза короче, чем в государственных программах. Let's do a thought experiment. Take the 1966 Soviet Luna 9, the world's first soft landing vehicle. Its system included a redundant engine, shock-absorbing inflatable balloons, and 3 independent radio altimeters. Now let's look at modern private missions. One engine, often without throttle capability, simplified navigation, minimal fuel reserves. The difference in approach is obvious. A legitimate question is, why don't government agencies hand over proven solutions to the private sector? The answer is complicated. First, many technologies of the 1960s are physically obsolete. Modern electronics requires new approaches. Secondly, as a NASA representative admits, we are learning to land on the moon anew ourselves. The last experience was 50 years ago. And the main thing is that commercial missions are fundamentally different. They must be cheap and massive, not ultra-reliable. Each failure brings in valuable data. After the IM-2 mission in 2025, engineers identified 3 critical improvements for the next vehicles. 1. Hybrid navigation, inertial plus optical. 2. Smart landing legs with touchdown sensors. And 3. redundancy of critical systems. We realize that you can save money on everything except the last meter of landing, stated the CEO of Intuitive Machines. At least 8 new private missions are planned for 2026 to 2027. Blue Ghost 2 from Firefly Aerospace deserves special attention. Its design has been radically redesigned after analyzing the failure of the first version. An emergency abort landing system, all new engines and triple redundant navigation have been added. Similar improvements have been made to the IM-3 in Japan's Hakuto-R.